All right, this is lesson 2 of geometry, having to do with angles. So an angle is formed by two rays that share a common endpoint, provided the rays are non-collinear, meaning they cannot lie on the same line. The vertex is the common point of the two rays, and the two rays are sides of the angle. So for example, this angle down here, you can see we have this vertex A, and the two sides of the angle are both rays. In the figure below, the angle can be named as angle TAP or angle PAT, or you can use a little angle sign here to refer to them rather than using the word angle. And since there are no other angles with vertex A, you can also call this angle A. So in this case, because this is the only angle with that vertex, we don't have to use the other two letters. We can just use the letter of the vertex itself. And note, the vertex must be the middle letter. The middle letter. Okay. So let's go ahead and name all the angles in the figure below. So I can see that here I have angle R, U, V, or there's the 1 right there, so I can also call that angle 1. And in addition, you can kind of see that there's this angle UTV right here, but there's only one angle with vertex T, so I can just call that angle T, and the other one angle V. And then in this figure, I have some angles too, so I have angle XAY. Does it matter if I go YAX or XAY? No, it means the same thing, just the vertex has to be the middle letter. So then you can go angle YAZ, and then you have that big angle XAZ as well. Now, can you just say angle A? Well, if we did, we wouldn't know which of those three angles it refers to. So because there's multiple angles with vertex A, we have to use three letters on each one. Okay. So when I say the measure of an angle, the measure of the angle is 45 degrees. What does that mean? Well, the measure of the angle is the smallest amount of rotation about the vertex from one ray to the other, measured in degrees. And so it's going to be between 0 and 180 degrees. So for example, if I have this angle right here, what's the measure of this angle? It's going to be the shortest distance between those two rays. Let's say it's like 50 degrees in this case. But what about this distance right here? What's that angle going to be called? Well, that's going to be the largest amount of rotation possible. And we're going to refer to that as the reflex measure of the angle. And so we can see here that this distance there, that degree measure is 136, and the other degree measure is 224. And this 224 is the reflex measure, and 136 is the measure of that angle. Okay. Now, to measure an angle, you're going to use a geometry tool called a protractor. And I have a separate video where I did this whole thing with a document camera. Because of the autofocus, unfortunately, it's not too clean of a video because it goes on and off. But if you prefer that one, you can watch that, and it goes over how to do it. But basically, you have a center mark here, and you want to line that up with the vertex. So you take that center mark and put it right on this vertex. So I was doing this angle right there. And then there's a 0 mark over on both sides of this protractor. Line one of them up with one of the rays or one of the sides of the angle, and then count up this way towards the other side. Notice there's two sets of letters, so make sure to start at 0 and count up 0, 10, 20, 30, and I think that was about 34 degrees in this case. And there you go. Now, how do you write that? Well, you'll notice here, you don't write angle ZAP equals 34 because that angle is a figure, right? And if it's figures, you don't use equal, you use congruence. So if you want to say equal, you have to put an M in front of it and say you're referring to the measure of that angle, and that's what is 34 degrees. Okay. So go ahead and measure each of these angles with your protractor at home and write out the degree measure. I will tell you this one here is 16 degrees. And this one should be about 164, and this one should be about 92 degrees. Okay, so two angles are congruent if and only if they have the same measure, the same degree measure. If they measure the same, they are the same. And they are also marked the same, right? So if you see a little marking here, that means that the angles are the same. So for example, if I had this angle, and I mark them congruent, I do that with a dash, and this dash marks them congruent, or maybe I could put 2 dashes and 2 dashes, and now they're the same. And finally, an angle bisector. So a ray is an angle bisector if it contains the vertex of the angle and divides the angle into two congruent angles. And in the figure below, ray CD bisects angle ACB so that ACD is congruent to BCD. So we can see these markings right there mean that it divides that angle into two congruent angles. That is an angle bisector. So let's look at this example here. Look for the angle bisectors and congruent angles in the figures below. So we have that RP bisects angle SRQ. SRQ. I'm just going to make sure I get a good Q there. Okay, so it divides that angle in half. The first figure, though, it's 43 and 44, right? So it's not an angle bisector. And the other one, while it has these two congruent angles, it doesn't divide any angle exactly in half. So in this case, we have one angle bisector. Name all the congruent angles. Well, let's see. We got angle SRP is congruent to angle PRQ, and angle YMN is congruent to angle EOM. And there's one other one which I didn't see right away. YMO congruent to angle EMN. See if you can see why that would be the same. It is actually related to the next topic of angle addition. If you have point D in the interior of an angle, then the two smaller angles add up to the larger angle. So in this case, CAD plus DAB equals CAB. That's called angle addition. You can use that in this example here. So if we're trying to find the measure of angle RTX, and we know that RTX is going to be 120 degrees plus the measure of angle RTS. So how do we find the measure of angle RTS? Well, that angle is just going to be 360 degrees minus all the other ones. And so that would be 43 degrees. So if that's 43 degrees, and the measure of angle RTX would be 120 degrees plus 43 degrees. And that will be equal to 163 degrees. All right, that concludes the video for lesson 2.